So for this section, which is 6.4, we're going to do the integration with tables. Now, integration with tables is being very useful when we're having like a really difficult integral to evaluate, right? Even though we learned many different techniques, but still, if we have a table in front of us that's easy to solve, to save us a lot of time. Because most of the time, when you do the integrations or derivatives, those are the tools to help you to get to what you want, right? So to help you to get, like if you are physics major or engineering major, you're trying to get the velocity, you're trying to get a distance, right? So those are the tools. So that's why right here, we can try to use a table of integrals to help us. Now, this tables is in the back of your book. So if you go to like the very last few pages, those are the table of integrals. I also scanned them and uploaded, right? So you can use it as a reference as well. So now the basic forms, we have done this before, right? So I always say that, when you're doing integral, check if you can do with the basic formula, right? Another next thing right here, they have some forms involving with radical a squared plus u squared. Now, most likely the u right here is the variable, right, and a is a constant. And now the next one is radical a squared minus u squared, radical u squared minus a squared, and such and such. So you're gonna have like many different, like general rules, the formulas. Again, you don't have to memorize them. I don't know many of them. All right, so but as long as you know how to use them, that will be great. So let me show you some examples for this table of integrals. So just connect this really quick. So now, for example, if I want to find integral of, now example 1, if I want to find integral of e to the negative 2x times cosine pi x dx. So for some integral like this right here, now normally what we're gonna do is integration by parts, right? So this such integral right here is doable, but it's just a little bit difficult to do that because for this integration by parts, you have to do, I think that you have to do twice, right? So you got a sine first, and then you're gonna get a cosine, and then you're gonna move the integrals. So it's gonna take a while. So now let's take a look at our table right here. So if I'm doing this table, just share the screen again. So if we're looking at the table, now we're doing e to the x times a cosine pi x. So let's see. If you go to the very last page right here, then you should be able to see it. So we need e to the some constant x, and also we need the cosine of pi x. So this is the, I think this is the one I'm going. But you know what? Let me make this a little bit bigger. Yeah, so this is the one I'm going. So I'm gonna do this one. All right, number 99. So number 99 here, let me just copy the formula really quick. So e to the au cosine bu du. So that equal to e to the au over a squared plus b squared, and then a times a cosine bu plus b times sine bu, and then plus c. Okay, perfect. I'm going to use this for my question. So now if you look at the question we have right here, we have integral of e to the negative 2x, and then cosine of pi x. So now in this case right here, now that is just corresponding value, right? So a, that means is going to be negative 2, and then pi right here is going to be our b. So that's pretty straightforward. So a is equal to negative 2, b equal to pi. And then we're just going to plug them in, right? So it'll be e to the negative 2x times cosine pi x dx. and that equals to e to the negative 2x, and just change your u into x, right? U equal to x over, now here we're gonna have negative 2 squared plus pi squared, and times negative 2 times cosine pi x, and then plus pi times sine of pi x plus c. Right, and now of course, if we want to make this look a little bit nicer, right, so we'll do e to the negative, e to the negative 2x over 4 plus pi square, right? And now everything else, I will just leave it in there. I will not risk the algebra right there. All right, so just leave it like that. Now this one right here is pretty straightforward. You can just plug in the formula, boom, and you get your answer. But for some problem right there is you cannot really using your formula directly. Like for example, if I have some integral of square root of x squared plus 6x dx. Now for some integral like this right here, again, this is doable by hand, but again, it's just probably a little bit more difficult. So now if you go to your table, I believe there is no table that will match exactly. So that is the problem right there by using the table, because the table is very general. So sometimes it's very difficult to find the matching one. So you have to do some algebra right there. So need some algebras to use the table. Okay, so now we have radical x squared plus 6x. Now let's take a look. Do we have anything can match it? So then this one, let's see. I don't really think there's anything can match it, because we in our table we have forms involve a plus bu. We have radical u squared minus a squared, radical a squared minus u squared. But we just don't really have any of those. Let me just share my table one more time. So doesn't really have those ones that we want, right? So we want x squared plus 6x. So if we can get rid of that x with 6, then problem solved. But unfortunately, we can't. So now in this case, leave us really no choice. So what I'm gonna do right here is I'm gonna complete the square. So I still want to get rid of that 6x right here. So when you're doing a question, doesn't matter what kind of question you're doing. So you gotta look at now, where is the problem? I need to solve that problem. All right, so you gotta watch out, all right, for that problem. So that's where you're gonna start. So now in this case right here, now my problem right here is this is 6x. So if I have 6 by itself, I can do. If I have x, maybe not, but I want to get rid of that. So now one way to get rid of that right here is I will do a complete square. Because when I complete the square right here, then the 6x will become one part of my completing square. And then I'll have some constant left. So that probably will solve my problem right there. So let's complete the square. So I have x squared plus 6x. Now, because I have this 6x right here, then the term I will need to plus is going to be this 6 over 2 squared. All right, so now again, if you already know how to do the completing square, that's perfect. Just bear with me. And then because I do not have this term originally, so I need to get rid of that. All right, so now for this 3 terms right here, so I will take, when I do the completing square, I will take this x, I will take this 6 over 2, which is a 3, and I will take this sign, the plus. So to put them together, and that will give me x plus 3, and then the perfect square. All right, so that's how I do the completing square. And now I'm gonna subtract the 6 over 2 square, which is a 3 square, right? So which is equal to 9. So I kind of changing my integral right here into this square root of x plus 3 squared minus 9 dx. So that will almost look like our table, right? Our table having like radical a squared minus x squared, radical x squared minus a squared, radical, what's that, a squared plus x squared, such and such, right? So table have those forms. So now we have that something squared minus a constant square, right? So now what I can do right here is I can let, for example, I can let u equal to x plus 3. Just do a simple substitution right there. Then I will have du equal to dx. So then in that case, I'll change that into u squared minus 9 du. And now at this point, of course, you can ask me, can I do, trig substitution? Trig substitution is perfect. You definitely can do that. Trig substitution works. But also, if you want, you can use it by table. And table is very easy to use for now. So you have radical u squared minus 9. So that should be straightforward now. Let's take a look at the table again. So if you have getting involved with u squared minus a squared, so let's go to that, which is this one. This forms involving this. And now that will be just number 39, right? And then we don't even have like a u squared outside or over u underneath, right? So it will be just 39 right here. So let me just copy my answer really quick. So it will be u over 2 radical u squared minus a squared minus a squared over 2 natural log of u plus radical u squared minus a squared and then plus c. All right, perfect. I'm just going to use that. All right, so now here I have the integral of radical. Now basically what I have is u squared minus a squared. So this is a table I have. So for by number 39 here, du. So I'll have my a equal to 3, or in another word, I probably just need a squared. So a squared equal to 9. So I'll just plug that into my formula. Oops. So that's going to be u over 2. So it will be u over 2, and then the radical u squared minus 9 minus 9 over 2 natural log of u plus radical u squared minus 9, and then plus c. All right, and now we're going to put the u equal to x plus 3 back. So we're going to have x plus 3 over 2. And now inside here, you're going to do x plus 3 squared minus 9. But in another word, this x squared plus 3 minus x plus 3 squared minus 9 is supposed to be just your x squared plus 6x, right? So then this is where that comes from. The x plus 3 squared minus 9 coming from here, x squared plus 6x. So you can do x squared plus 6x if you want to. All right, and now we're going to minus 9 over 2 and the natural log of was that u is x plus 3 and plus radical. I will do x squared plus 6x and then plus c. And that's it. So that will be my answer. So radical of x squared plus 6x dx. All right, so now here just show you like 2 simple examples for you to see like how we're gonna do the integration with the table. Now, some of them you just need to find the correct number and plug in the corresponding value. But some question like this, the second example, you had to do some algebras. Now, most of time, not 100%. Most of the time, some algebras you need to do is like completing square. That's the one I see most of the time you have to do, completing the squares. All right, or maybe something like, for example, if you have let's say u squared plus 5 in that case, then you probably have to do, okay, so my a squared equal to 5, which means my a will equal to radical 5. Or something like that, right? So maybe it's not a perfect square. But the completing square, that's the common one, very common one that you most of the time have to do. All right, so this is for the integration with the table. Now, in your homework, you're gonna see many questions. Well, you're gonna see more questions, and you're gonna can give it a try. And also, it's good for checking your answer by like during the exam time, because you don't really have access to the internet, and this is the best way to check your answer, right? But sometimes your answer may look different from what they have because we probably didn't simplify it, or maybe the way they do is kind of look different from what we have, but they actually the same. So it needs a little bit time to adjust and to see if they really means the same. Okay, so then I will see you in the next video.